Hello everyone, today I am going to explain the solutions of AtCoder Beginner Contest 238. I will explain the solutions for problem A, B, C, D and E. So let's see the first problem. In first problem we are given a value n which can be up to 10 to the power n, and we have to check whether 2 to the power n is greater than n square or not. Now we cannot evaluate the value of 2 to the power n as it will be very large and we cannot store that in integer. So we will check its binary representation. So we know that any power of 2 has only one set bit in its binary representation, and any other number which is not a power of 2, it will have more than one set bits. Now for example 8, it has binary representation like this. Now for n square we can get its MSB by bit manipulation. Now how can we know that which number is larger? So which number has higher MSB, that number will be greater than the other number, because for example if one number is like this and another number has more set bit but like this, so this number has MSB at 0, 1, 2, 3, 4th bit, and this number has MSB at 3rd bit. So obviously the number which is greater higher MSB, that number will be larger. Also if both numbers have equal MSB, then the value of n square will be larger, because since this n square is not a power of 2, so it will have more than one set bit. So it must have one set bit in any of these position, at least one more set bit. So this number will always be greater than this number. So that is all we have to do, and here I have stored the value of n square in m. Then after that I have evaluated the MSB of n square here, and then I have checked if my MSB of n square is greater than equal to n, because n is the MSB of 2 to the power n. Then we print no, otherwise we print yes. So that was problem A. Now let's see problem B. Now in problem B, the statement was a bit complicated. Like we will be given some angles. So the problem was the Takahashi will cut pizza using a sequence A of length n according to the following procedure. First, make a cut from the center in the 12 o'clock like this. Then do n operations. Rotate the pizza and AI degree clockwise, then make a cut from the center in the 12 o'clock direction. So what it says is, like for example, first it is given 90 degree, so we will rotate this pizza 90 degree clockwise and then we will cut from here, and thus it will look like this. After that, what we will do, we will move this clockwise 180 degree, and then again we will make a cut from here. So these are the steps, and after all the cuts are done, we have to tell which cut has the largest angle. Now actually what we can do in this problem is, we can consider an array of size 360, because the total angle of a circle is 360. Now initially we will be at position 0, and every time we will be, let's say, in input given x, y, z, w cuts. So initially we are at this position, we will make a cut at x. After that we will make a cut, this distance is x, this is not distance, this is actually angle in degree. Then we will move y degree more and we will make a cut here. After that we will make a cut here by z. Now let's say our w cut is like this, this is up to 360, but our w cut is this much. So what we will do, we will after this point we will come back to the 0 degree, and from here we will further go forward. Thus after all the cuts are done, we will get a array like this, like 0, 1, 1, 1, 0, 0, 0, 1, 0, 1. So this 1 positions implies that these are the positions where a cut was made. Now we have to get the cart which has highest angle. So we will evaluate the consecutive carts, I mean the distance between them, and whichever consecutive cart has maximum distance, that will be our answer. So once I show you the code, it will make more sense. So here the first we have taken the input in our array A, then I have created a array of size 360, and initially all the indices are filled with 0, which means there are no cut. And initially we start from point 0, so my current is 0, and I go one by one of our input array, and currently I am at position current, and I have to go forward by AI degree. So I find my next position by it. Also I do mod 360, so that if I cross my array's range, I mean 360's range, then I will come back to 0, and from there I will again start going forward. So that this way I have found my next position where I will make the cut, and I have put 1 at that position. 1 means that I have made a cut there, and then my next position will be my current position, because after I have made a cut from I was here, let's say I have made a cut here. After that I will made let's say I have now y degree cut. I have to cut after y degree, so my y degree will be counted from here. So once this is done, my array contains all zeros and ones, and now I will store those indices where the cuts were made in our another array st. So after that, initially one more thing we have to keep in mind, that we have, let's say, made cuts like these positions. Now this is one angle, this is another angle, this is another angle, and another angle is this, like this much plus this much, because when we carve this line to make a circle, these will be the lines. So this is like this, and the last is also connected with this. So initially I store 360 minus st dot back plus st0 as my answer, which is nothing but the last cut, the distance between the last cut to the first cut. And after that I go from index 1 to the end of the st array, which we are storing the consecutive cuts indices, and I get their distance, and I store the maximum distance in my answer, and finally I print my answer. So that was problem B. And now the problem C. Actually I had some difficulties in understanding this problem at first because of the statement, which was not very clear to me, but this problem is actually very easy. So what this problem says is that fx is the number of positive integers at most x with the same number of digits as x. We have to find f1 plus f2 plus fn modulo this value, because the answer can be very large. Now let me explain further that what fx is. So let's say fx, let's say x is 16. So f of 16 means how many numbers are there before 16, or up to 16, how many positive numbers are there up to 16 which has 2 digits, because 16 has 2 digits. So how many numbers are there which has 2 digits? The numbers are 11, numbers are 10, 11, 12, 13, 14, 15, 16, which is 1, 2, 3, 4, 5, 6, 7 values. So I guess that they have also said that, yeah. So f of 16 is 7. Also you can say f of 3. So 3 has 1 digit, so we have to say we have to evaluate how many positive numbers are there which are less than equal to 3 and they have 1 digit. So the numbers are 1, 2 and 3, so f of 3 is 3. So f of 4 will be 4. So thus we are given a value n. We have to calculate f of 1 plus f of 2 plus dot 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 f of n. Now n's value can be up to 10 to the power 18. Okay, so now one thing to observe here is that f of, for every f of x I am showing you some value. For 1 it will be 1, for 2 it will be 2. For 3 it will be 3 because there are 3 values 1, 2, 3. Thus for 9 it will be 9 values 1, 2, 3, 4, 5, 6, 7, 8, 9. After that, when it starts from 10, it will be 1 because at max before 10 there are no positive number which are 2-digit number, because the 2-digit number starts from 10. So it will be 1. For f of 10 will be 1. F of 11 will be 2 because there are two numbers 10 and 11. So like f of 101, it will be 2 because there are 3-digit numbers 100 and 101. Now we have to calculate the sum. So since f of n is 10 to the power 18, we cannot do it linearly. Like we cannot just for every f of 3 we cannot add 1 plus 2 plus 3 because that will give us TLE. So another thing to observe is that the values are how the values are changed. So for first 1 to n, how many numbers are there? There are 9 numbers. Okay, now each number 1 to 9 have value 1 plus 2 plus 3 plus 4 plus dot 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 plus 9. After that the number starts from 10 to 99. All these numbers will again have how many numbers are there? There are 90 numbers, and these values will be like 1 plus for 10 it will be 1, for 11 it will be 2 plus 3 dot 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 plus up to 90 numbers, so plus 90. After that for 100 to 999, these are the 3-digit number. For them there are 900 numbers, and again the values will be calculated like 1 plus 2 plus 3 plus dot 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 plus 999. Okay, now we have to calculate this value and also take mod, but we cannot calculate this value linearly. So we know that for first n natural number the sum is n into n plus 1 by 2. Thus we can calculate this value. Now how will you take it? I will show you the code now so that you can understand better. So initially I have taken n, input n. See, I showed you that the numbers, how the numbers are changing. Like first we have to calculate sum of 9 first n natural numbers, then 90, then 900, because 10 to 99 there are 90 numbers, 100 to 999 there are 900 numbers. Thus it will be 900. It increases by power of 10. So initially my capacity is 9 and currently my answer is 0. Now while n is greater than 0, I am trying to get, like for example, if my n is 234, I have to get the value for f of 1 plus f of 2 plus f of 3 plus dot 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 f of 9 plus f of 10 plus dot 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 f of 99 plus f of 100 plus dot 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 f of 234. So f of 1 to f of 9, this is n into n plus 1 by 2, where n is 9. Again f of 10's value is 1, 2, it will go up to 90. So this value again will be 90 into 91 by 2. And this much, how many numbers are there from 100 to 234? There are 134 numbers. So the sum will be 134 into 135 by 2. But we also have to take modular. So initially my capacity is 9. Now I check if my capacity is greater than equal to n or not. What this implies is that, let's say my number is 5. Okay, now initially my first capacity is 9. I showed you that it will be like 990, 900. So if my current number is less than 9, then I will take sum up to 5. I won't go for up to 9, right? Because for 5 the answer will be f of 1 plus f of 2 plus dot 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 plus f of 5. So that is what I have done here. If my capacity is greater than equal to 9, which means my n is less than equal to capacity, then first I multiply n into n plus 1. This mod mul function is nothing but I have written here, it is just multiplying using modulo, because we have to take modulo. The modulo is here stored. Then I also have to divide it by 2. Now n into n plus 1 by 2, we can do the divide directly, but since here modulo is involved, like n into n plus 1 is like n into n plus 1 modulo, so we cannot divide this value directly by 2. That will give us wrong answer. So a divide b mod m, this value can be evaluated as a into inverse of b mod m. Okay, so first I take the value n into n plus 1, then I take the inverse of 2 and I multiply it with my mul, like mul, and then I add this in my answer. So what I have done, like n into n plus 1, I have first calculated this, then I have taken n into n plus 1 into inverse of 2, and this value I have added this to my answer, and then I have break from the while loop. And if my capacity is less than equal to n, which means, like for example, my number is very large number 4 5 6 7 and currently my capacity is 9, so obviously I will take all the 9 numbers, because after that I will get f10 up to f99 and dot dot dot. So in that case I take the multiplication with capacity, I take capacity into capacity plus 1, then again I do the same inverse into by 2, which is modular division, then I add that in my answer. And also, since there are 4 5 6 7 numbers, I have already calculated the sum of first 9 numbers, first f1 to fn, then I have decreased my n by capacity. Also now I have calculated up to 9, so next time my capacity will be 90, because next time it will be 1 plus 2 plus dot 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 plus 90. So I have increased my capacity by multiplying it with 10, and finally when I come out of the loop I print the answer. So that was all for problem C. Now let's see problem D. Now problem D, so in problem D we are given two integers a and s, and we have to check whether there exists two number x and y such that their AND is a and their sum is s. So let me explain it more. So let's say you are given a value a and you are given a value s. Okay, now you have to check if there exists two positive number x and y such that their sum will be s and their bitwise AND will be a. We don't have to find those numbers, we just have to check if that exists or not. Now how can we do that? So there will be few observations. The first observation, let's say for this number 1 and 8. Okay, let me take a better example. Wait. So let's say the numbers are 8 and 14. No, these ones does not exist. 8 and 17. No, this one does not exist also. So these all numbers does not exist there in combination. So let's take the example 1 8. So AND is 1, sum is 8. We have to check if there exists any pair of numbers for which x and y will be 1 and x plus y will be 8. Now for any number, let's say we have AND value like this. So there are two numbers x and y whose AND is this. Now obviously in those all bits which are 1 of the AND, x and y must have 1 in those bits, right? Because 1 and 1 is 1. Otherwise if any one of these two is 0, then the AND will be 0, like 0 and 1, 1 and 0, 0 and 0, all of this will be 0. So what I'm trying to say is that in the AND, if any bit is set, then for x and y that bit must be set. So that was the first observation. Now let's say I put 1 as 0 0 0 0 1 and 8 as 0 0 0 1 0. Okay, now this is for sure that x and y both will have 1 in their 0th bit, because the AND, this is the AND value and this is the sum value, the AND value has 1. Now after that we need to check another thing, that x and y both number must have the same must have set bits in all those positions of in the AND value in which bits they are set. Like what I'm trying to say, let's say x and y are the numbers, okay, which for whose AND is A and whose sum is S. So x and y both have let's say A has set bit at position 2, 4 and 5th bit. So x and y both will have set bit at their 2, 4 and 5. Okay, so this is the number till now. Now we have to change, I mean these two numbers sum also have to be S. So let's think that the numbers, let's take two sets, like the numbers which have set bit let's take two set A and B. So A will store those bits for which x and y both store the set bit, like here 0 1 2 4 and 5. These bits are set for both the numbers, and there will be few bits for which either x or y will be set. Let's say those are m n, 2 bits. Now we have to check, like I have written it here, yeah. So what you have to observe is that we have already gotten the set bits in both the numbers x and y. We know that these bits at least have to be set bit in both numbers. So our total sum of x plus y, like x plus let me clear it here. So what I'm trying to say is x plus y is equals to s, right? This was given. Now we know that both the numbers contain same set contain at least some same set bits. So like a plus a plus x equal to s. So what this means, that both the numbers have some same set bits. So I have, like this is x, this is y, so both the numbers have same set bits, so it is nothing but 2 into a, and also we have to additionally add some extra value so that it can be equal to s. So I am making you understand this, like, so what we need to get is, we have to evaluate that is it possible to get this value x or not. So how can we check that? So see, there are few numbers which will be same in both the numbers, and after that there will be few numbers which will I mean x might have 0 here and 1 here, and x might have 1 here, y might have 0 here. So like they don't, there are, after I take the same set bits, the rest set bits cannot be there, in there cannot be any bit where both the numbers have same set bit. So I just check that, like I have to evaluate the value of x, is it possible to get x or not. So initially my a plus x equal to s, so 2a plus x equal to s, from there x will be s minus 2a. So x also must be greater than equal to 0, right, because we have to get the positive numbers. So first I check if x is less than 0, then the answer does not exist. Also a and x, the end of a and x is not equal to 0, then also the answer does not exist. Why so? So I have already explained that for let's say x and y's and is this number, so both x and y will have set bit in these positions. Okay, now their sum is something else. Let's say their sum is 0 0 0 0. Let's say their sum is 1 0 0 1 0. So since this bit is set, what I'm trying to say is that, see, these are the same set bits, so we don't have to think about these ones, but the rest of the set bits, there are in this position either x or y will have set bit and the other won't have set bit, right? So because if both have set bit, then in AND in their result of AND, there will also be set bit in that bit also. Since that bit is unset, so either one of them is set bit, otherwise both of them are off. So if the number x and y, I mean if I take the AND of a and x, because AND, like I have taken the number 0 1 1 0 1, this is one value, and the other values like 1 0 0 1 0, this will be another number. It's not x, like it is the extra number which we need. If these two numbers, see, these two numbers cannot have set bits at the same position, so we have to check if these two numbers AND is not equal to 0, that means there is no common set bit in these two numbers, then the answer exists, otherwise it does not exist. And finally the problem E. The problem E is a bit tricky, because the problem states that we are given a secret integer sequence A, and we don't know what the sequence is, but we know the size of it, which is n. After that we are given q queries, where we are given in each query we are given a value of sum of a li to a ri. We have to tell, is it possible to determine the sum of all the elements in a to a n. So the problem states that there is an array which we don't know, but we know its size. Now after that we are given some prefix sum of some ranges, like let's say in 3 queries, first we are given the sum of this range, then we are given the sum of this range, and then we are given the sum of this range. So using these queries, can we get the total prefix sum of the whole array? Is it possible to get or not? Now one thing to observe is that for prefix sum, if we are given prefix sum L to R, which means A of L plus A of L plus 1 plus dot 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 A of R. This is the value of this. Now you need to notice one thing, that if let's say we already have given this value, like we know the answer for this range, okay, now we are given another range like this, so can we get this total value range answer from using this two range? The answer is yes. Why so? Because if we add this range, and if we remove this overlapping range, then we can get the total sum of this range. Thus we have to tell after q queries whether is it possible to get the prefix sum of the whole range or not, which asks us to tell whether we can get the value from index 0 to index n. Not index 0, I mean index 1 to index n, but we will initially start from index 0, because why so? Because let's say a of LR. So this value is nothing but prefix sum 0 to R minus prefix sum L minus 1 to R. So if for given this range, so anyhow if we can get the value of prefix sum up to this, like if somehow anyhow we can get the value up to this point, like if this is I, we can get the prefix sum up to I minus 1, we can use this value and then we can combine with that our current range and we can get the answer up to this. So thus we have to check whether is it possible to go to traverse from 0 to index n using the given ranges. So this how can we do that? Actually I have done that using graph and DFS. So initially I have taken the input integer n and q as input. After that I am given the L and R values. I have taken those inputs and I have created a graph where I have created edges between L minus 1 and R. Why so? As I have told that for A of LR we can use this LR, I mean we can come to this LR only if we know the answer from for L minus 1, because if for this range, to use this range we need to come up to here. I mean if we know up to the answer of the we know the answer till this range, only then this will be useful to us to go forward. So this range actually connects us to come here from I minus 1. Now we don't know if we can come till I minus 1 somehow or not, but if we can come here, then we can also come here using this L to R range. So I have just created the edges and then I do a DFS from position 0, because initially position 0 is actually nothing. So we have to check if we can reach till n using these ranges. So that in DFS function, initially I have called DFS function from 0, because we will start from 0 and we have to come to n. Now I mark my current index as true visited. After that I check if my current index is n and if it is visited, that means we have reached n, then I just simply return. Otherwise, let's say I am currently at this position 0 and let's say we were given two ranges in queries, like one was 1 to 3 and another was 1 to 6, right? So which means that we could come to 6 from 0, we also could come to 3 from 0. So we will explore all the possible paths, like from all the possible points where we can reach from 0, and thus we will simply call DFS, and after that we will come out of the function. Then after calling the function we will check if at any point we reached n or not. So if we somehow reached n, that means we have some connecting ranges which have led us from index 0 to index n. So using those ranges we can somehow calculate the prefix sum, because if the ranges were like this overlapping also, if we add all these ranges and we just subtract these overlapping values, we will finally get the total prefix sum. So thus we check if our nth index is visited or not. If it is visited, then yes, we can get it, otherwise we cannot get it. So this was problem E. So I have explained from problem A to problem E. If you have any confusion or queries, you can always ask your question in the comment. So thank you for watching.